Hola. So my name's Elton. I work for Docker. My grandmother was Spanish, so when I was young, she taught me how to count to 10, and a lot of very rude words, and that's all. So the rest of this talk is in English, apart from the word hola. So I'm going to talk today about why containers will take over the world. So this is a talk about container adoption. It's about what people are doing with containers and why it's a good investment for you to learn, for your businesses to invest their time and effort in moving things to containers. There's three themes we're going to cover. The first is the bulk of the talk. It's about the use cases. It's about what people are doing with containers right now. Like, this is not tomorrow's technology. This is people are using stuff now. And then towards the end, I'll talk about why it's a safe bet to move to containers, because the platforms are open, because they're flexible, that sort of stuff. OK, and the aim really is to get you to understand that containers are going to take over the world, and you really need to get on board. Otherwise, you're going to be left behind, and you'll be crushed by the container revolution. OK, so number one, because they solve real problems. So I'm going to walk through the 5 main use cases that people are doing with containers today. And at the end of this section, I'll try and remember what those 5 are, so you can test me as I'm going through. The first one is moving to the cloud. Everyone's moving some or all of their stuff to the cloud. And it's a very important thing to do, because it gives you the scale, gives you the flexibility. It should save you a lot of money. But it's hard to do, especially if you've got a large application landscape. So take this example here, really simple example. I've got 3 applications. I want to move them to the cloud. They're all distributed apps, so they've all got several components. And at the moment, they're all running in my data center. And the way I run them to get isolation between those components is everything has its own VM, which is what happened after the great VM revolution, that you could have these virtual machines and get better utilization for your data center. What people ended up doing is just running every component in a dedicated VM, because it's easier than trying to work out which components can coexist together. Just get the isolation, make sure everything is in its own VM. It's horribly inefficient, but it does work. Now, if you want to move these things to the cloud, you've really got 2 options. You either go all in on a particular cloud, and you look at each of these components, and you look at the offerings from that cloud provider, and you build those apps for that cloud provider. So if I was moving to Azure, I could take each of these components, find the bit of Azure that matched best, and use that for that component. So I can use app services, I can use Service Bus, SQL Azure, the API gateway, all sorts of things. There are components for pretty much everything that I want to do. There's a couple of problems with doing that. The biggest problem is that's a project for every application. So you need to look at each component. You need to work out how you're going to make it work in the cloud. You need to look at how you deploy it with the scripts, how you package it, how you run it and maintain it. And there may even be code changes involved. You may have to go back to code to say, to get the best use of this PaaS option, I need to change code to make it work. The other problems are, when you've done that, when you've made that investment to move that project over, you've moved it to Azure. And Azure is a fantastic platform. I'm a Microsoft MVP. I'm all for Azure. But the investment you've made, it moves it to Azure. You can't then take those new packaging components that you've got and then run it in AWS or run it back in your data center. You've moved one way. You've invested a lot of time to get to one place. And the other problem is, when this is running in production, when you're running in your non-production environments, it's totally different. Like, if you're running on some VMs in a test environment that you've still got in your data center, they won't be running on the same platform that you run in production. And your devs on your laptops will be running in something totally different. So you've moved to the cloud, and you've got this disparity between your different environments. And wherever there are gaps, there are potential holes that cause you problems. So the other option to move to the cloud, and then is to go IaaS, is to just replicate what you've got in your data center. So rather than find out all the bits of the platform that I can use, I'm just going to rent virtual machines in the cloud and just replicate what I've currently got. So I can reuse whatever scripts I'm using at the moment, whatever automation tools, reuse them all. All I've got to do from my cloud provider is ask them to provide me some VMs, some connectivity, some storage, which they all do. And that means I probably can move this stuff around between different clouds if I want to, or I can run on the data center, or even on my developer laptop, so I can have the same experience everywhere. But what I'm really doing is I'm replicating my inefficiency. But now I know how much it costs me to be inefficient. So if I were to run a test environment with a few VMs and a production environment with high availability, I'm going to have 20 or 30 VMs running. And each of these components is in its own VM just for isolation. That's the only real reason. But now I can see how much that isolation costs me. So in this example, it's going to cost about $5,000 a month to run those 3 apps in a production and a test environment, which may be worthwhile, and it may not, when you can see that these are running in VMs, and the average utilization of the platform is like 5% CPU, because they're just not using all the benefits that you can get. So the other option, rather than go PaaS and limit yourself to one cloud, or go IaaS and pay a lot for infrastructure you're not using, is to move to containers first. So if you were to take each of those components and put it in its own container, firstly, you're giving yourself a lot of flexibility. Those containers I can run in Azure, I can run in AWS. If I want to, I can spin up some VMs on a native cloud provider and run those things in containers. And it's portable. I can run that anywhere. When I'm running this on my laptop in development, it'll be the exact same platform, the exact same stack that I use in production. And in each of my environments, I'm using the same tools to deploy it and to manage it. So those containers are going to be the same everywhere. And if I want to run in the cloud, again, I can go for that kind of lowest offering from the provider and just spin up a bunch of VMs. But I don't need so many VMs. I just need a few VMs to host my container platform. And so then I can just have a few VMs for test, a few more VMs for production to give me that high availability. But overall, I'm going to get a lot better utilization. I don't need to have a whole bunch of VMs that are sat there for isolation purposes, being duplicated for HA. I can have the minimal number of VMs to give me HA and condense all my container workloads on there. So in this example, which is kind of made up, but actually it's based on figures that we've got, instead of having 30-odd VMs, you could do with 10 for your 2 environments. And instead of spending $5,000 a month, you'd be spending like $1,500. So this is the first use case. This is what people are doing. They're looking to move to the cloud. They're moving to containers first as an intermediate step, which means they can go to any cloud, and they're going to pay a lot less when they're in the cloud. It's a bit boring, like it's a boring use case, but if you're involved in saying, we can save 70% of our cloud bill, you're going to get a promotion or a pay rise or something like that. So that's the first one. OK, the second one is new applications. So you can take your existing apps and move them to the cloud without really changing them. But there's also a whole wave of new applications that your company are going to be working on. And the new style of applications, the new architecture, are all kind of rooted in container ideologies. And these architectures like microservices, like 12-factor apps, like event-driven architectures, they all kind of emerge from the fact that I can have lots of small components, I can rapidly deploy them, I can rapidly scale them, they can be upgraded independently of each other. They leverage that to give you a really flexible architecture. So there's a good example of that. This is a demo app that's on GitHub that you can go and play around with. This is a microservices application. Each of these components runs in its own container, or multiple containers for high availability. It's deliberately complex because it's showing you that you can do all sorts of interesting things with these architectures. So each microservice owns its own data, and there are different databases in use, there are different programming languages in use. All those components talk to each other, and as a whole, they provide a single application. But say it's an online retail application. So you could go on there onto the website, and you can order some stuff and put some stuff in a cart. Each of those components is coming from a different set of containers, which might be in different languages. There's Java there, there's .NET Core, there's Go. They all talk to each other really seamlessly. And the way you deploy something like this, you could build something like this years ago with yesterday's technology, but the way you deploy it is incredibly complicated. So I've got 12 different components here that all have their own ideas about how you deploy them, how you manage them, how you look at the logs, how you connect to an instance to see if it's still healthy. All those things that come with a lot of baggage. When everything's in a container, everything looks the same. So you manage it all in the same way. OK, so all those little components, and this term cloud native, fits in with this big diagram here. So I'm going to spend maybe 10 minutes on each of these little blocks. No, obviously not, because we'd be here for till Friday. Each of these little blocks is a technology that fits in nicely with these new architectures. A lot of them are open source. They fit in with different areas of what you're trying to do. So there's orchestration in there, there's Docker Swarm, and there's Kubernetes. There's infrastructure there, so there's a lot of hashy stuff in there. There are components that help your services talk to each other. There's security in there, all sorts of stuff. This is really interesting because although it's a great, huge wall of logos, there are paths through this that are emerging as kind of standard best practices now. So people who've been doing cloud-native applications for a couple of years are saying, actually, what you want to do is you want to have this path through, and you'll pick 5 or 6 technologies, and that will give you your monitoring, because there are standard ways of doing monitoring, standard ways of doing logging, that sort of stuff. It's really interesting that you can leverage some of this stuff and just drop it right into your application. You don't need to worry about having a highly scalable message queue and investigate a whole bunch of commercial options, because there are at least 3 that are in the cloud-native landscape that are already bundled to run in containers. So all you do is run those containers, add them to your app, and everything communicates that way. OK, so this is the GitHub link. I'm going to show you how to deploy this. So I'm going to go over here and annoy the cameraman. So I've got, on this laptop, I've got a Docker cluster running. Let's have a look at this. Docker node ls. How is that for size? Is that OK? Is that OK? So I've got a cluster running in VMs on my laptop. I've got 3 servers, 3 VMs that are all running Docker, and I've joined them together as a cluster. People familiar with this orchestration technology? This Docker Swarm? People heard of that? He's heard of it. Excellent. So I've got 3 nodes in my swarm, 2 Linux nodes and a Windows node. So they're all joined together. I can run Windows containers and Linux containers on that cluster. They can talk to each other. It doesn't matter that some are Windows, some are Linux. So what I've also got in here are some application manifests that describe apps that I'm going to deploy. So the first one is this microservices app. And to deploy it, I do docker stack deploy. Stack is just a name of a collection of components. In this case, it's a whole application. And then the file I want to deploy it to, and then I give it a name. And that's it. So I'm going to show you in a second what that's actually doing. It's going through that YAML file, which describes my application, and it's creating services for each part of that architecture that I've shown you. So let's show you what it's actually doing here. This is the application manifest that I'm deploying. So this is in YAML. It's a kind of semi-human readable thing. This is what I'm going to deploy to production. Actually, this is what I would also deploy on my laptop if I was a developer. I'd use the exact same file to do this. If you're not familiar with it, if you've never seen this before, it's actually pretty straightforward. It tells you what it's doing. There's a big list of services here. They've got a friendly name, like here's my front-end service. This is where users go in to view the application. And this is the name of the Docker image. So that's the package that contains that component for my application. It's version, so it's a particular version that I'm deploying. And it's going to start that service up. There are a few other things. In this case, there are some ports that it uses. I'm mapping to a particular port, so I can get access to that component. And because I've got a multi-platform cluster, I've got a little hint in here that says, this is a Linux component. So Docker will work that out for itself, but it works it out by trial and error. And it says, this is a Linux image. I'm going to try it on this node. That's a Windows node. It fails. I'm going to try it on this node, which is a Linux node, so it succeeds. But by putting that little bit in to say, this is Linux, I can get rid of the trial and error bit and tell Docker that this is a Linux component. So each of these things is one of those boxes from the architecture diagram. There's an exact map of what my logical architecture looks like and what my physical architecture looks like when I deploy it. I've got databases in here. Some are MySQL, some are Mongo. There's about 100 lines here, 100 lines of YAML, which seems like a lot when you first look at it, but actually this is deploying a very complicated application. Multiple databases, multiple front ends, multiple back ends. Can you imagine how you would deploy this in a non-homogeneous way, like with containers? You'd have, in the Windows world, you'd have a Word document that was about 500 pages long, with lots of screenshots telling you to do this and click that, and make sure you copy this file here and copy that file there. None of that happens. It's all in this document, which you can read and which you can deploy, and which the machine will use to deploy the application. OK, so it's created all those things. It's created those 12 different components. What I've got here, if I list out the stacks, I've only got one application running. It's got those 12 services there. When I type those Docker commands, Docker is sending the command line request to the Docker API, which in this case is a remote API that's running my cluster. That cluster also has the front end installed. So I can go and look at the front end here. And this is the UI for the cluster. So I've got my, let's clear that down. Hey, come back. I've got my node list here that shows me all these things are running. I've got my Windows node. I've got my 2 Linux nodes. I've got a list of all the stacks that are deployed, and there's the new one I've just deployed. That's my sock shop application. And in here are all the services. Now, they're all green, so they're all up. They're all running. So in the time that it took me to describe what was going on, it's all been deployed. It's running across the Linux nodes in my cluster. Some are on node 1, some are on node 2. I don't know which ones. I don't care. It doesn't really matter. Docker will make sure that they're always running. The number 1 for each of those says, in my deployment document, I've asked for a single container for each service. Now, if I want more scale and I want high availability, I can have multiple containers for each service. And Docker will take care of that stuff for me. So what I've got here, these are all the different parts. And the front end is the only part that's visible to users. And this link here tells me how I can get to it, because Docker knows that it's been published. It's a SOC application. It's a SOC shop. Don't worry too much about what it actually does. But what you're seeing here is all these components working together. So this is the front end. If I go and look at the catalog to look at the SOCs that are available, this is coming from a different component, which has its own database. So the catalog component is coming from a completely separate service. If I add this to the cart, and then go and look at my cart, this is all coming from different services. They all interact as if it was one thing, because it is one application, but they're all coming from different components in different languages. If I want to, I can add the shipping address, and I can complete the order, and then there's a fake fulfillment service that shows me the order's been fulfilled. When I'm looking at this stuff, if I want to manage it, I can go back to my UI, and I can go and look at the front end, and I can see the containers that are running. And there's only one, because I've only asked for one so far. And I can go and look at the logs, and although it's kind of tiny, these are all Node.js. So the front end is a Node.js application. The way I deploy it, the way I manage it, I don't need to know or care about that. I've got logs here. I can connect to the container and look inside if I need to. The other thing I could do is I can go and look at a different service, let's say the catalog. And I can work with it in the same way. This happens to be a Go application. I can go and look at the logs for this application. And these are all coming from Go. It's a Go application running on Linux. When I deploy my Windows application shortly, you'll see it behaves in exactly the same way. So I can take all this cool new stuff, and it's really easy to deploy it, and it's really easy to run. And you can go to GitHub. You can pull down that repo. You'll get that application manifest that I've talked about, and you can deploy that on your laptop. If you've got Docker for Mac or Docker for Windows, you literally do the same thing. You do Docker stack deploy, or you can use Docker compose, and you'll get the exact same output. No matter where you are, because those images are versioned, because those packages have the exact software version in them, wherever you run this, you're going to get the same output. OK, I've done the demo. So far we've had going to the cloud and running new applications, new application architectures. The other big thing, which is to some people a surprising development of the container movement, is taking existing applications and moving them to containers, and using the underlying container platform to modernize your old application architecture, to make that old thing look a bit more like the new thing. So as an example, the demo I'm about to show you is an ASP.NET 3.5 WebForms application. So for those of you who aren't familiar with the Microsoft stack, that's a web platform that's been around for 15 years. 15 years? 12 years. So I could take a 12-year-old application that I currently deploy like this, with a SQL Server database in one virtual machine, and my web application in another virtual machine. That's my version 0. Version 1, I can move both of those to containers. I can run SQL Server in a container. I can run my web application in a container. I don't need to change code. I don't even need to look at the source code if I don't want to. If I'm currently deploying it with an MSI, or if it's a Java app, if I've got a jar file or a WAR file, I can just take that and put that into a container image. I don't need to go back to code. And if this might be where it ends. That might be the end of the journey for this particular application, because it's an app that's being used regularly, but it's not being developed. So there are no new features coming. So maybe we're going to leave it here. But if it is being additively worked on, if I've got a team who are working on this project, then maybe I'm going to use this as a platform to modernize the architecture and fix some problems by taking advantage of the fact that I'm now running in containers. So version 2, maybe I take out a feature that is talking to the database, and I put a message queue in. And I put a message queue in a container, and I take out the old feature, and I run that in a different container. I use the message queue to plug them together. And now I've got an asynchronous workflow for something which might have been a performance bottleneck. I can fix that performance issue. I get high availability, running everything in containers. So I'm not having an issue of how do I deploy these new components? How do I make these things work together? Because they're all just containers. I'm just going to add new lines to my application manifest and run them all in the same way. Version 3, well, I've got a message queue now. I can attach some other feature on the back of that message queue, listening for those messages, and maybe I can run some analytics, all in containers. And then version 5, maybe I want to change the front end of my application. And I don't want to have to do a full regression test of the whole legacy app just to get a change to my home page. So maybe I can run that in a new component. So when I need to change the home page, I just change that one container rather than a whole bunch of them. And this is, you're going to use exactly the same sort of stuff to make this happen. So again, back to my cluster, where I'm still running my sock shop application, I'm going to deploy another stack here. So exactly the same terminology, docker stack deploy, deploy. The file I'm going to use is called signup version 1, and I'm going to call it signup. And this is described in exactly the same way. There's an application manifest that describes the services I want to deploy. In this case, there are just two. There's a database, and there's my application manifest, my application image. And the database is SQL Server with my own schema already applied. So I've got a database with my schema ready to run. And the application is my .NET 3.5 application. Now, the way I've packaged that is using a Docker file. And this is the Docker file that packages that image. There are two parts to this. So I could have used an MSI if I had one. But as it happens, I've got access to the source code. So what I'm doing is in the second part of the image here, I'm using an image from Microsoft, which has all the stuff I need to run my application already installed. So I've got Windows Server, I've got ASP.NET installed, I've got version 3.5 of the framework, which is this old version. That's all looked after by Microsoft. They take care of updating the images, doing the security patches, that sort of stuff. So but that first line that says from gives me all the prerequisites I need. And the rest, I'm just setting up my application. So I'm using PowerShell, which is my favorite shell, because I'm fundamentally a Windows person. And I'm setting up my new website. And the final line is I'm copying the content of my website. And I'm copying it from earlier on in the build process. So what Docker lets you do is it lets you build from source in one part of your Docker file. So the first part, I'm building the source code. And in the second part, I'm packaging the output into my final image. So this is all I need. These 17 lines, and at least 4 of them are white space, is all I need to take my 12-year-old application and put it into a Docker image in such a way that when I change the code, I can just rebuild the image, and I've got a new version ready to go. OK, so during all that talking, my stack should have deployed. So let's have a look at the stacks I've got now. So I've got my original sock shop that's running and my new sign up with 2 services. It's the same cluster that I've deployed to. So when I go and look at the UI, I've got my sign up stack in there now. I can go and look at the services, and they're both up and running too. These are running on my Windows node. Now, I know that because I've happened to define these as Windows services, and they won't run on a Linux node. So I can't take a Windows Docker image and run it in Linux. And I can't take a Linux Docker image and run it in Windows * which I can talk about later on. But fundamentally, a Linux container runs on Linux, a Windows container runs on Windows. But if they're all in the same cluster, if I've got a cluster of Windows and Linux machines, I can run any type of application in containers there. So my application is a really basic demo application. If I browse to my Windows node, it's going to take a while to start up. And this is always fun for a presenter, because I know it usually starts in 20 or 30 seconds, but after that 20 or 30 seconds, if it doesn't come up, what do I do? So what's happening here is it's an old application. It's a legacy application. It doesn't start instantly, like my new microservices app does. Whew. So what's happening is when I send in the first request, it hits a cold container. The container isn't ready to serve the application. So the first user hits that delay while the web server spins up and it gets my application ready and it connects to the database and all that sort of stuff. This is a fake newsletter application website. So I can go and click on here. And the thing it talks about, Play with Docker, is real. That's a real website. You can try Docker out. But the newsletter is fake. I know it's connected to SQL Server. I know it's connected to my database container because these drop-downs come from the database. So my database image has got my schema deployed and a bunch of reference data. So my Windows app is talking to my SQL Server container that's running in my cluster that happens to have also a bunch of these Linux containers running. And my SOC application is obviously still running. So this is still here. Happens to be on a different bunch of servers, but it's still there and it still works in the same way. So if I look at my node list here now, what I should see is it tells me the CPU usage, and it's still pretty low. There's a bit more memory usage there, but I'm condensing more and more applications onto my cluster, getting more and more use out of it, and I can condense as many as I want to. And the point where I need to add more capacity, I just add another node to this cluster. All I need to install is the operating system, Windows or Linux, and then Docker, and then join it to the cluster, and it can take part and run containers. OK, so I can use my cluster to run brand new applications, and to run old applications, and to power my move to the cloud. So what else can we do? We're running out of things to talk about, because that's most of what people are doing nowadays. The next one is innovation. So I can take my old apps and move them. I can take my old apps and use the platform to extend those applications, add features to them, make them look more like a modern app, and I can run my modern apps. And what about the future? Well, there are some key movements in IT which are becoming a reality, which are underpinned by containers. So this idea that's key to everything is being able to package a particular version of a particular set of software in a portable image and run it anywhere. That's empowering a lot of stuff. So the three things I'm going to mention very briefly that are all helped by containers, if not dependent on containers. The first one is IoT. That's a Raspberry Pi. So IoT projects are really interesting because one of the biggest challenges with IoT is once you've got your devices out into the wild, they're gone. You have no control over how you do an update, how you push a software update, if the user's even connected to the internet, how you manage getting new stuff onto that device is a really difficult problem. Unless you're running your device application in a container, because then you can build your images and you can use the delivery part of the Docker platform to push those images out. So you can run the exact same version of the code on a device locally or an emulator, and when you're ready, you push it out to your registry, which is your store of all the images. And then when the devices are ready, they can go and hook in and pull that stuff down, which solves one of the biggest problems with IoT, of actually keeping these things up to date. Another one is machine learning. So machine learning suffers from a lot of the same problems that ordinary IT projects have. I've got this component that can do stuff, but it has a bunch of dependencies, and maybe it has some data that I want to ship with it in certain circumstances. Again, you can solve those issues by taking your TensorFlow application, bundling all the dependencies that you need to run it inside a Docker image, and then running it in a container. And anyone you give access to can have all those packages ready to go. And maybe you could even bundle some models with it if you want to deploy that stuff. I'm not going to talk about blockchain because I don't really understand it. So the next one I'm going to talk about is serverless. So serverless is becoming actually really interesting to an awful lot of people. What serverless means is you have a bunch of servers and then you try and forget about them. There are a whole bunch of serverless frameworks that are emerging on top of Docker, on top of container platforms. So you've got things like AWS Lambda and Azure Functions that are fantastic. You go on to their platform, you just write some code, you click a button, and it deploys. It's brilliant. But it's back to that PaaS part of the equation, where you can't really take that and then run it somewhere else. Whereas the open serverless frameworks, I'm going to show you one called Nucleo, but there are others. OpenFaaS, OpenWhisk, Galactic Fog, they've all got bizarre names. They take the same idea, but they use Docker to power it all. And it means you can take the same portability stuff that you get with the rest of your applications and use it for experiments with serverless. So I'm going to show you a demo. I'm going to do this in a slightly different way. So I'm not going to deploy this to my stack the way that I have done so far. And the reason for that is, let me find my demos. Over here. So let's say my stack here, my cluster, might be my pre-prod environment or some sort of test environment that other people have access to. And I don't necessarily want to deploy this serverless thing everywhere. So what I'm going to do is I'm going to deploy it directly as a container on my host. So this big long command here, I literally copied and pasted it from the Nucleo website. So the Nucleo website says, if you want to try this out, install Docker, run this command, and this is what will happen. It'll start running the Nucleo server on your machine, or in this case, on my cluster. So it's running on the same cluster, but it's not showing as a stack, because I haven't deployed it as a kind of production-ready application. I just want to play around with it. It's not a service, because it hasn't been deployed in that way. It's just running as a single container. So down here in the containers, so my 3-node cluster now has 50-odd containers running my legacy application, my new application, and now my serverless framework. So this is the Nucleo playground. If I browse to the Nucleo playground, which is 8070. OK, that's firing out. So this is it's a particularly unimpressive UI, but this is a serverless framework running in containers on my cluster. And I've deployed it in such a way that it isn't really scalable and all the rest of it. I just want to see how it looks. So down here, I can pick a function, and it kind of works just like Lambda, if you're used to Lambda, or Azure Functions. I just have some code here. This is some sample code. It's a Node.js. All it does is it runs an API, and it returns you send it a date, and it adds some time to it. So I can just click deploy, and it packages that in an image, it runs it in a container, and within a few seconds, it's up and running on my cluster. And this output here tells me what random port it's using. So if I'm thinking, oh, this is interesting, I want to see how this works, I can use an API client like Postman, and I can send in a request, and that's the output now. So all I've done is I've sent in a time, and it's given me the current time plus however many hours I asked for. And it's a really simple way of trying this stuff out. And of course, that's not the only thing you can do, obviously. That's just the most simple. There are, you can use Go, you can use .NET Core, you can use Java, and it all works in exactly the same way. You just write the code, deploy it, and away you go. You don't have to worry about what's happening there. So my cluster now has a serverless framework, an old application, a new application, all running, all being managed and used in the same way. OK, so. And the fifth one is DevOps. Hooray, because that's why we're all here. So DevOps, you've heard several times today, and you'll hear many more times over the conference, is not about tools. And it absolutely isn't about tools. It's more about doing things in a new way, getting people on board, getting people working together better. But actually having a new way of doing things really helps to underpin that. So I don't know if you're familiar with this approach, which is popular in a couple of the consultancies in the UK, this CALMS framework. And all it means is these are the things you need to think about when you're moving to DevOps. So you need to think about your culture. You need to think about automating everything. You need to make sure you're lean so that there's no waste, as Marcus talked about this morning, no waste in your pipeline. You need metrics to understand what you're doing and what your software is doing. And you need to be sharing. You can't have siloed teams that are solving the same problem in different ways. Now, that's really good, but actually, it's hard to do that stuff, especially if you're in a company that's been doing it the opposite way of that for the last 10, 20, 30 years. If you make a significant technological change, it can underpin a lot of that stuff. So if you were to move to Docker first, then suddenly it makes that a lot easier. It makes it obvious that you're making these changes. It forces people to do things differently. Number one is culture. So suddenly, what used to be the dev team and what used to be the ops team are working on the same artifacts now. They're both working on the Docker files. They own that jointly. That's part of the project. They both work on the application manifest to deploy these apps. They work on those things jointly. And speaking the same language and using the same tools is a huge removal of barriers for people who've maybe never even worked together. The automation part is just baked in. There's no real way to run containers. You can build a container, and deploy some software, and then save that as an image and do it all manually. But it's really hard. It's much easier to write the Docker files, to automate it all for you, to build the application manifest that describes all your components. And you've seen when I deploy it all, I just write a single command. And that's really simple to put that into a CI process. The lean idea, I can have each of these components in containers. I only need to update what's necessary to change. I don't need to do a full regression test, a full bunch of updates of a big application. I just change what's needed. And the metrics part is really interesting because you can kind of, outside of the technology, you can have a process that says we can understand what's happening here because we can track all our artifacts through the different stages. And within the technology, it's really easy to build really useful dashboards on top of container-based solutions, because each container can expose some useful metrics, and then you run a container that scoops them up, and then you run another container that has a dashboard and shows you everything, and that's all part of that CNCF landscape that I showed you. There's some really good technologies like Prometheus that make it easy to do that. And the sharing stuff, well, that whole landscape is full of open source software that's enterprise grade and production grade. You just drop straight into your solution. You don't need to go and build up a whole bunch of custom software. You can bring it off the shelf. The shelf's much bigger now because all sorts of technologies are being bundled up as images that you just run in containers right in your solution. And going back to that very first one, the common artifacts, it's one of the biggest things, I think. So imagine the old world where you've got Linux and Windows technologies. Most big companies have a mixture of both. If I think about how I package those things, there's a whole raft of different technologies that different parts of the team will use, and how I ship those things, and how I manage those things. And people with a historically dev or historically ops will come in on different sides of that, and they'll all be using different versions and different sets of technologies, and they won't be familiar with anything the other side uses. But when you start moving these things to containers, it all becomes so much simpler, because everything becomes standardized. So my brand new Linux Go microservice is packaged using a Docker file. And my .NET 3.5 12-year-old legacy application is packaged with a Docker file. Those Docker files produce images, which I share somewhere, and then I run them using some sort of orchestrator, be it Docker Swarm, Kubernetes, whatever. When everyone's talking the same language, owning the same set of artifacts, using the same tools, it becomes a lot easier to call them one team. OK, so 5 things. Let's try and remember. Cloud, new applications, old applications, innovations, and DevOps. So that's pretty much everything that people are doing in the IT world today, which is why the title of this talk is Containers Are Going to Take Over the World. To get there, you have to make some investment. Like, not a lot, not as much as you would to move to a custom PaaS delivery, but building those Docker files, building those application manifests, it's going to take some work. And the other part of why people are happy to do this is because it's safe to do that work, because this stuff's flexible. You're not going to be tied in to products from Docker or from any particular vendor. So this is my horrendous spectrum slide. This is all about taking your existing landscape, your existing applications, and how you can run them in a containerized world. I'm not going to go through all this. There's a blog post here if you want to actually go and read what this stuff is. What it's saying is you're going to have applications, maybe 10, maybe 1,000 applications, that you want to do something with. Maybe that's because you want to move them to the cloud, or you want to modernize them, or whatever. You can choose exactly what you want to do here, and the platform will support you. It doesn't mandate that you have to do things in a certain way. As long as you can write a Docker file that will build, that's it. That's all you need. It can have an MSI in there. If you're on the red side of the spectrum, I've got applications that I want to move to the cloud, but I don't want to work on them. I don't want to do anything with the source code. That's fine. You write a Docker file to deploy your MSI, build an image, run it in Azure. Right across to the other end of the spectrum, that I've got this old application that's core to my business. It's this huge monolith. I want to break services out. I want to do it I want the freedom to use .NET Core or Go or Spring or whatever. It supports you with that too, because each of those components will be a Docker image. No matter how big that application gets in terms of components, you're still going to manage, build, and deploy it in the same way. So you're not told to do things a certain way. You can bring whatever you need for each of your applications. And the third one is because they're open. And this is really important. This is going back to that lock-in idea. The Docker file doesn't mean you have to use Docker. It's an open format. And the same with all those bits and pieces. So the demos I've been showing you have been using Docker, the Docker container platform. But you don't have to use Docker. So you could take those exact same images, so the compiled packages that you get from your Docker files, and you can run them in Service Fabric. You can do that today. You can have a cluster of, so Service Fabric is Microsoft's orchestrator. You can have a cluster of Linux and Windows machines, take those same images, and run them in Service Fabric. Shortly, you'll be able to do it in Kubernetes. Kubernetes added Windows support. It's in beta at the moment, but it's pretty good. Eventually, you'll be able to do that in Mesos, which is Apache's orchestrator. So you can take the investment that you've made, the work in your Docker files and the work in your application manifests, and run those on different orchestrators. And that can come from any different vendor, or even just run the open source stuff. You're not locked in. And so all the key parts of the workflow, you take your Docker file, you build an image, you ship it somewhere where other people can access it, and then you run it as containers. They're all open. They're part of open initiatives, they're open APIs, there's open source implementations. So you're not tied into one particular vendor. You're not going to make all this effort and then find that you're locked into a particular platform. OK, so here's a whole bunch of links. If you want to explore this more, the final two links are the demos that I've been doing today with the old application, but they're in a lot more detail. So I talk about how you break out the steps. I deploy it to Docker and show you how you can make those containers work together. There's a dev-focused version, and there's an ops-focused version. If you want to try the platform, go to that URL. And we are in Barcelona in December for DockerCon EU. DockerCon is the industry's container conference. It's in San Francisco in June, but if you can't make it, come here in December, and it's bound to be fantastic. My name's Elton. Thank you for listening. And I think I've maybe got a few moments for questions. I've got maybe 1 minute. Let me go back to the other slide, so you can take a photo of that if you want to. No? OK. Well, I'm around the rest of the day. I've got stickers. If you want to catch me, I've got some Docker stickers and a few other bits and pieces. But thank you for listening. I hope you found it useful.